Right now, there's a wound on the face of the Sunday, a deep black tear the size of 50 times Earth, and it's pointing a gun directly at our orbit. But you won't see it on any mainstream evening news, MSM. Why? Because it didn't explode. There was no dazzling solar flare. No spectacular complex energy cloud, CME, ripped from its surface and flung into space. By all usual sensational standards, the sun appears, completely still. Yet, behind closed doors, space weather forecasting centers have just issued a geomagnetic storm warning. Grid operators and aerospace engineers are quietly receiving instructions to prepare. A chilling contrast. There was no explosion on the sun, yet Earth is poised for a collision. If no actual explosion occurred, then what the hell is hitting Earth? And why isn't the collision itself the most terrifying thing, but rather, it's a ruthless time machine programmed to go back? Before we delve into the raw data that the predictive models are trying to mask, I want to hear from you. Leave a comment below. Where are you watching this video from, and at what time? And what do you think about our entire digital civilization, from GPS, the power grid, to the 11,800 satellites out there being eroded by an invisible, cyclical force? How many more loops can our system withstand before a link shatters? Let me know your thoughts. This isn't the story of a single storm. This is the story of a recurring mechanism, an orbital environment being stretched to its limit, and the terrifying fragility of humanity's technological infrastructure. Now, sit tight and make yourself a cup of coffee, and let's begin. If you're an astronomy enthusiast and you're just looking at common photos of the sun today, you'll find it boring. There are no fiery arcs of plasma tearing through the surface. Any eruptions that have occurred in the past few days have been directed in harmless directions in space. By all conventional optical standards, the sun is in hibernation. But in NOAA's room in Colorado, forecasters aren't looking with their eyes, they're looking with data, and the numbers are screaming. Look at the solar wind, the constant stream of charged particles blowing from our star. Normally, it maintains a baseline speed of around 340 kilometers per second, a quiet humming of the solar system. But in just a few hours, forecasting models indicate that this speed will skyrocket to over 600 kilometers per second, possibly even reaching 700 kilometers per second, doubling the speed limit, and this is where things get absurd. The KP index, a measure of the magnitude of global magnetic field disturbances, had been flat at near zero for days, perfect stillness. But then, in less than 12 hours, forecasts indicated it would jump to KP6. Make no mistake, KP6 is no breeze. KP6 is when our magnetosphere is struck by a giant alarm bell. KP6 is when the aurora borealis is pushed far south, your GPS signals start to go off track, and national grid operators are glued to their inductive current monitoring screens. Such a violent, rapid transition usually only happens when the Earth is engulfed by a massive cloud of plasma from a CME explosion. It's basic physics. You need a shockwave to hit a magnetic shield to create a storm. But today, no shockwave, no plasma cloud. Scientists call this a clean high-speed stream event. To put it simply, Earth is being punched. But no punch was thrown. To put it simply, Earth is being punched. But no punch was thrown. A static system couldn't be flipped into Hurricane KP6 in just 12 hours if it were truly healthy. The harsh truth that weather reports ignore is, our magnetosphere didn't flip over because the push was too strong. It flipped because it was already stretched to the brink beforehand. It carried an invisible payload that we were unaware of. So, if it wasn't a plasma bomb from the sun, where is the real killer lurking in the shadows of the solar system? The truth lies in something the media often misnames. If you access the Solar Dynamics Observatory, SDO, ultraviolet imaging database right now, you'll see something that looks very wrong. A dark patch stretches across the sun's disk, as if a giant hand has just scooped away a chunk of the star. Most people look at this image and assume the obvious. It's a wound. Even its scientific name is misleading. Coronal Hole. The word hole implies an empty space. A hole, a missing piece of matter. But that's not the truth. A coronal hole is not a hole at all. No chunks of the sun have disappeared. Its core is still there, still fusing hydrogen into helium at 15 million degrees Celsius, just as it has done for the past 4.5 billion years. What you're seeing in that satellite image isn't a missing piece of matter, it's a fault in the magnetic field structure. Under normal circumstances, the Sun's magnetic field lines act like giant invisible cages. They rise from the surface, bend through the corona, and then pierce back inwards. These magnetic cages trap the superheated plasma inside, compressing it. The compressed plasma glows brightly under ultraviolet light, that's why most of the Sun looks so bright. But at the Coronal Hole, the magnetic field isn't closed. The magnetic field lines are broken, extending out into space, reaching even the most distant planets in the solar system. There are no more cages, no more magnetic traps, and when the superheated plasma sits on an open magnetic field line, it can only do one thing: spill out. It flows into the solar system at speeds that can exceed 800 kilometers per second. That region looks dark not because it's a hole, it's dark because the plasma that should be glowing there has escaped. Don't call it a hole, call it a wide open magnetic gateway, a cosmic highway. It's the Sun's exhaust pipe, a pressure valve where the Sun's atmosphere finds an outlet and continuously pumps matter out into space day after day. And this is where the harsh truth comes to light. A coronal mass ejection, CME, is an explosion. It's sudden, violent, hurling billions of tons of matter, and then it's over. Hours later, the Sun is back to its original state. But the Coronal Hole isn't an event, it's a structure. An explosion is a punch. This structure, it's a leak, a persistent, relentless torrent that never truly stops. It can last for weeks, even months. You can avoid a punch if you have an early warning system, but how do you avoid a flood that never recedes? The Earth isn't being smashed, it's being hydrofracked into its magnetic defenses. And worst of all, this massive torrent isn't even directly setting our magnetosphere on fire. When the plasma stream rushes out of the Coronal Hole at 700 kilometers per second, it doesn't enter empty space. Between the Sun and Earth is a distance of 150 million kilometers, and that space is occupied by the slow solar wind streams of particles drifting at only half the speed generated in the preceding days. Imagine a sports car speeding down a highway at 150 kilometers per hour, but ahead of it is a convoy of trucks crawling at 70 kilometers per hour. What happens? The sports car can't fly right through the convoy of trucks, it's forced to crash into their rear. In astrophysics, this collision creates a phenomenon called the co-rotating interaction region, CIR. At this collision boundary, matter is compressed to an extreme degree. The particle density skyrockets. The magnetic field twists, distorts, and becomes chaotic. The CIR turns into a swirling shock wave, paving the way for it to sweep through the solar system. And here's the second truth the news is hiding from you. The hole in the Sun didn't directly hit Earth, not even the fast wind itself. What really shattered our defenses was this chaotic CIR compression wall. But Earth's magnetosphere is very selective. It's a perfect magnetic fortress. It doesn't open its doors to just any energy flow passing through. To penetrate this fortress, the CIR needs a key, a specification that space meteorologists call the Southward Bz component. When the chaotic CIR wall's magnetic field swirls and inadvertently points straight south, it creates a perfect opposite angle to Earth's northward magnetic field, like two oppositely polarized magnets attracting each other. At that very moment, a devastating physical phenomenon occurs: magnetic reconnection. Earth's protective shield is torn apart, the gate swings open. Enormous energy from the solar wind rushes into the core of our system, triggering a geomagnetic storm of G2 or even G3 magnitude. And this is what leaves supercomputers helpless. We can see the hole in the Sunday, we know how wide it is, but what is the true intensity of the CIR compression wall, the exact moment it hits? And most importantly, will that South Bz key be in the lock for 4 hours or 14 hours? It's an absolute blind spot. Our billion-dollar early warning models can only tell us about 30 to 60 minutes before the CIR actually hits. 30 minutes to prepare for an attack on the entire global power grid and satellite network. But while the public and the press held their breath, counting down the minutes until this CIR wall struck, they were unaware that the tragedy had already begun. A silent, unseen destruction had been unfolding right above our heads for exactly 14 days. While the media and the public were glued to their screens, counting down the days until the CIR wall made landfall, they missed another storm. A storm with no thunder, no dark clouds, and not even appearing on your weather reports. It was in the outer radiation belt, an area located between 13,000 and 60,000 kilometers above the Earth's surface. And this silent storm wasn't about to happen. It had been wreaking havoc in the area for 14 consecutive days. The sensors weren't lying. The magnetic flux of high-energy electron streams specifically, particles exceeding 2 megaelectron volts, MeV, had been locked at above 1,000 pfu particle flux units for 2 weeks straight. On the worst days, data peaks ripped through the graph, soaring to 1,700 to 3,200 pfu. At space operations centers, NOAA issued constant Alert 3 alerts, warning satellite operators that their systems were being bombarded with radiation. Put yourself in the shoes of a satellite operations engineer. You know that a brief radiation shock is normal. Satellites costing hundreds of millions of dollars are designed to withstand a data spike for a few hours. But 14 days? That's no longer a shock. It's a relentless and relentless bombardment. Scientists call this state of radiation marinade. The engineer looks at the screen and realizes a horrifying truth. The orbital environment has not returned to normal. His system gets no rest. This completely changes how we assess the survival of digital civilization. When that CIR wall finally hits Earth, it won't encounter a healthy, vigorous army of satellites. It's crashing into machines already preloaded to their limits. They've been carrying an invisible burden for the past 2 weeks. Like a bridge already cracked under tens of thousands of heavy trucks, you don't need an earthquake to bring it down. You just need another brick. A system already on the brink doesn't need a massive solar explosion to collapse. And the way these radiation bursts finish off a satellite isn't as noisy and fiery as Hollywood portrays. The real killer is Deep Dielectric Charging. When thinking about the death of a satellite in a solar storm, most people, and even Hollywood, imagine a spectacular explosion scenario. A blast of energy hits, solar panels spark, and ground control screens go out instantly. But the reality in space is far colder and more merciless. Most satellites don't die in a flash of brilliant light. They die slowly, silently, and painfully from within. Let's familiarize ourselves with the mechanism of deep dielectric charging. When extremely high-energy electrons, those is greater than 2 MeV particles we just discussed, bombard a satellite, they don't bounce off. They pierce through the metal armor. They dive several millimeters into the internal structure and embed themselves in the dielectric materials within the circuit boards. They sit there, accumulate, hour by hour, day by day. You can't see them. The satellite's measuring camera reported everything was normal. But inside, an electric field was swelling up like a ticking time bomb, until one moment. The insulating material could no longer contain that enormous electrical charge. It collapsed. And the result was a phenomenon called internal electrostatic discharge, ESD. Simply put, a tiny, sharp lightning bolt struck directly into the satellite's brain. What could this lightning bolt do? It could cause a bit flip in memory, creating a hallucination in the navigation system. It could incinerate a critical sensor. It could create a cascade failure, causing the satellite to spin wildly in space. Or, worst of all, it could destroy the entire system. But here's the most terrifying detail, the truth that drives space engineers crazy. This fatal electrical discharge doesn't necessarily have to happen at the peak of the storm. Your satellite might survive the storm perfectly. The press celebrates. NOAA lowers the alert level. And then, a few days or weeks later, on a sunny Tuesday afternoon with a perfectly calm magnetic field, the satellite suddenly dies. Because the trapped electrical charge inside remains there, just waiting for one last small vibration to explode. The media will never link that death to the previous week's space storm. It's recorded as a random system failure, a death of unknown cause. A satellite failure is an accident, but what happens when thousands of satellites, the backbone of the global internet, of GPS navigation, of the logistics supply chain and the world's financial trading system, are all immersed in this radiation pool? They don't collapse all at once to create a glorious apocalypse. They die, a slow, agonizing death. Lifespans are shortened, services are disrupted in inexplicable ways, networks become fragile, and that's why we're asking the wrong questions. When looking at space weather, we always ask, how strong is the storm today? But scientists know that's a question for amateurs. The real life or death question that no supercomputer dares to answer with certainty is, the real question of life and death isn't, how strong is today's storm? The question every space engineer fears facing is, how many cycles of torture has our system endured without a chance of recovery? In materials engineering, there's a concept called metal fatigue. A steel beam can easily support a static load below its maximum capacity. It doesn't break, but if you force it to bear that safe load, repeatedly 10,000 times, the steel beam will crack and fracture at a pressure far below its maximum capacity. The very act of repetition is a destructive mechanism. Our orbital infrastructure is suffering from the same curse. Not mechanical fatigue, but electromagnetic fatigue, thermal fatigue, and software fatigue. The Earth's space environment doesn't react in a linear fashion. When a high-speed wind rushes in, you'd think the electron load would simply increase. But no. Sometimes the initial radiation decreases as particles are scattered back into the atmosphere. But soon after, the flow resumes, pumping energy, and the radiation belt re-establishes itself with far greater intensity. Loss, then recovery, and finally exaggeration. The magnetosphere never reaches equilibrium. It's always in a state of agitation. This leads us to a deadly illusion of modern civilization. We believe that a system that's still running means it's healthy. A satellite that hasn't failed means its lifespan hasn't been shortened. A GPS service that hasn't been interrupted means it hasn't reached the brink of collapse. That's a suicidal naivety. We are designing super infrastructures to withstand peak loads, and assuming they will have time to rest, cool down, and recover between disasters. But what will happen to the power grid, to satellite internet, to the entire backbone of the digital world if the universe doesn't give us time to rest? What will happen when disaster is no longer a random event, but becomes a deadly schedule, wound up every 27 days? The universe doesn't operate on randomness. It operates through time machines and ruthless physical loops. From Earth's perspective, the Sun takes about 27 days to complete one rotation. Astronomers call this the synodic rotation, and this 7-day rhythm is what reshapes the entire concept of risk we face. Because the coronal hole is a physical structure firmly attached to the surface, it rotates with the Sunday. Imagine it as a giant magnetic lighthouse. When this hole rotates towards Earth, high-speed winds sweep through our magnetosphere. When it rotates to the back, the winds are released into harmless space. Earth is temporarily safe. This is the biggest difference, a chilling fact when compared to the catastrophes often portrayed in the media. A CME explosion comes, devastates, and goes. It's an end. But with a coronal hole, the danger disappears from view. But that doesn't mean it's gone from the system. It's just lurking in the shadows, silently spinning and waiting to knock again. The real haunting lies in its relentless rhythm. In just 12 hours, a tranquil magnetosphere can be flipped into a frenzy. In 14 days, the radiation belt can maintain enough heat to boil a satellite's dielectric system. And every 27 days, that nightmare returns, not a beat out of place. When a coronal hole is durable enough to last through 6, 8, or even 10 consecutive rotation cycles, the risk loses its element of surprise. This leads us to a chilling conclusion. This is no longer an event. This is a schedule. It has become a periodic erosion of our civilization. Human infrastructure from terrestrial power grids to telecommunications satellites was designed to survive rare shocks. We built this world on the belief that catastrophe is a rare, long-term event. But there's a question strategists dare not ask. Were those hyper-connected infrastructures designed to survive a rhythm of agonizing stress? Almost monthly? And what's really being tested out there isn't just metal machines. Gone are the days when space weather was only a concern for a group of NASA scientists or a few military officers on special missions. Today, space isn't out there. It's in your pocket, running along the power poles on the street and coordinating the pulse of the entire global economy. Take GPS, for example. Most people only think of it when they need directions to a coffee shop or are waiting for a ride. But that's just the tip of the iceberg. GPS, Global Positioning System, signals don't just provide coordinates, they provide something infinitely more important: extremely precise time synchronization, precision timing. It's the clock that counts the rhythm of our entire civilization. Without GPS timing signals, financial markets couldn't validate millions of high-frequency transactions per second. The national power grid couldn't synchronize alternating current across transmission lines stretching thousands of kilometers. Mobile telecommunications networks started crashing because their towers were out of sync. And that vital signal had to travel through the ionosphere. When the 2 7-day storm cycles swept through, the ionosphere was churned into a chaotic plasma soup. GPS signals were bent, scattered, or completely swallowed. Millions of dollars worth of precision agriculture were temporarily blinded. Commercial airlines flying over polar cap absorption lost shortwave HF radio communication and were forced to make emergency diversions, burning millions more tons of fuel and tearing up schedules. But the worst wasn't in the sky, it was underground. Under the influence of a magnetic storm, something called geomagnetically induced currents, GIC, will run along high-voltage power lines for hundreds of miles. This malevolent current forces massive transformers into saturation. It generates harmonics, it heats up the insulation, and it erodes the lifespan of the equipment. The Quebec grid collapse of 1989 was a single disaster caused by a massive CME explosion. But with the Coronal Hole, we weren't struck a fatal blow. We were eroded. The power grids in Canada, Northern Europe, or North America didn't die immediately, but for months, the transformers heated up a bit, their lifespan shortened by several years. The sun isn't any more malevolent than it was millions of years ago. What has changed is us. Humanity has placed the entire survival of society on an infrastructure highly sensitive to magnetic fields. We have made ourselves perfect targets. And ironically, the thing most likely to bring down that system is the very thing we pay the least attention to. Because humans have a fatal blind spot in psychology. We only fear what is dramatic. Look at these two images and ask yourself, which do your instincts tell you to fear more? The answer is obvious. Human brains, programmed over millions of years of evolution, react to violent threats. A charging lion, a raging wildfire, a blinding explosion. We are designed to be alerted by things that are right in front of our eyes. And that's precisely why the media goes wild over CME, cosmic eruption, but is completely silent about coronal holes. CMEs are very cinematic. They have fire, they have speed, they're easily packaged into a sensational 1-0 word headline. But coronal holes? They're just a faint grey smudge in a photograph taken through ultraviolet light. You can't write a headline online that says, "Warning, a sunspot is slowly rotating and will reduce your satellite's lifespan by 2% in the next month." It doesn't generate clicks. It doesn't generate advertising revenue. But ask any systems engineer, and they'll tell you a paradoxical truth. Infrastructure fears far less dramatic things. The CME is like a punch to the face. Painful, devastating, but you can fall, get up, and bandage the wound. The coronal hole and its high-speed jet streams, HSS, doesn't punch you, it submerges you in water. The Earth isn't struck, it's immersed in a toxic electromagnetic environment. You can withstand a punch far better than being submerged in salt water for weeks on end. The scariest thing in this story isn't the storm itself. It's a deadly disconnect between what the public sees and what the system actually suffers. People look up at the sky and marvel at the beauty of the aurora, seeing it as a magical light show, but they don't know that behind that dazzling curtain of light lies an electromagnetic environment stretching every layer of invisible infrastructure, every satellite circuit board, every substation, to the point of groaning. The silence of the media has created a fog blinding all of humanity. We keep waiting for a great explosion to signal the end, while the erosion has long begun. And if you think this is just a strange phenomenon, an outlier about to pass, then look at the solar cycle clock. Because what we are witnessing may not be an exception. It could be the prelude to a new normal that will last for many years. The sun isn't a machine running at a single speed. It breathes. And each breath lasts 11 years. In astrophysics, we call that the solar cycle. Everything we've discussed, from violent CME explosions to silent coronal holes, is governed by this cosmic clock. We are currently in solar cycle 25. Over the years, we've witnessed the rising phase and the solar maximum. It was a period of magnetic chaos, tangled sunspots, blazing fires, and continuous CME explosions that captured the media spotlight. But according to historical predictive models, that violent peak seems to be behind us now. Earth is preparing to enter a completely different phase, the declining phase. You might think that declining means peace. The general public will see less sensational news. They'll assume the sun is asleep. But for space systems engineers, the declining phase is when the real system killer comes into play. During this phase, coronal holes no longer remain obediently at the poles. They migrate. They stretch out, crossing the equator. Scientists call them transequatorial coronal holes. And when a hole is located right at the sun's equator, it's perfectly aimed at Earth's orbital plane. If this cycle follows historical patterns, then what we are witnessing today is not an anomaly at all. It's not an exception. It's the opening shot of a new normal that will last for years to come. There will be fewer devastating direct blows, but periodic saltwater immersion will become commonplace. High-speed winds will batter our systems month after month. Satellite systems and power grids will no longer cope with incidents, but must find ways to survive in a systematically toxic environment. And if you think that losing billions of dollars to replace satellites, or a local power grid collapse on the ground, is the most expensive price humanity has to pay, then you've forgotten a far more brutal truth. Humans are no longer sitting idly by under the shield of the magnetic field. We are stirring to take our proud steps into the depths of space. And those fragile biological machines called astronauts are about to walk right into the heart of this invisible torrent of radiation. When we talk about power outages or satellite failures, those are still losses that the economy can quantify. But humanity's ambitions don't stop at low Earth orbit. We're talking about Artemis, about returning humans to the moon, about the far-fetched dreams of colonizing Mars. And that's when the new normal of the solar cycle is no longer an economic problem, but a life or death boundary for human physiology. Remember the magnetic shield protecting Earth? The astronauts on the International Space Station, ISS, are orbiting 400 kilometers above the Earth. They are still deep inside that protective shield. Although they receive higher radiation doses than we do, the magnetosphere still filters out most of the most deadly particles. But the Orion spacecraft is different. Once you cross the magnetosphere boundary towards cislunar space, the space between Earth and the Moon, you enter true deep space. You're stripped of all your shields. Here, the high-speed wind from the Coronal Hole encounters no resistance. It strikes directly at the spacecraft's hull, and when electrons is greater than 2 MeV penetrate the alloy shell, they don't just cause deep dielectric charging on microprocessor circuit boards. They penetrate fat, muscle, and go straight into the cellular structure of the human body. They attack DNA strands, causing double-strand breaks. The human body hasn't evolved to repair this level of damage. If the sun were in its decay phase, and these high-speed currents, repeating every 27 days, became the background state of the space environment, then the picture for astronauts would change completely. A mission to Mars lasts 6 to 9 months one way. A base on the Moon requires a presence lasting months. They won't just be dealing with a rare CME explosion, where they can hide in a bunker for a few hours and then come out. They'll be immersed in a surge of intense radiation, lasting for weeks at a time, and repeating every 4 weeks, month after month. The media and tech billionaires paint a multi-planetary future as a walk in the park. They promise glass-domed cities and bustling fleets of spacecraft. But the universe never extended an invitation. With silent streams of particles, the sun is making the rules of the game clear. Deep space is not an environment for expansion. It is an environment that systematically rejects life. What is eroding our satellite systems today will erode the bone marrow and immune systems of tomorrow's pioneers, unless we discover some revolutionary materials technology, something that, even on paper, doesn't exist yet. The harsh truth is, we cannot conquer something that is silently eroding us according to a predetermined schedule. And as we pull our perspective back from deep space to Earth, looking at this entire domino effect on the verge of collapse, the most terrifying question is no longer what the sun will do. We've come a long way in dismantling an illusion. A dark area on the sun that seemed like a harmless physical phenomenon, a geomagnetic storm warning that appeared without any of the familiar explosions, an invisible surcompression wall, a radiation belt that had been boiled over, an army of satellites suffering from microscopic cracks within their dielectric cores without anyone knowing, and a 2-7 500-day time machine that turned the threat into a cruel schedule. This story, ultimately, isn't about the Sunday. The sun continues to do what it has done for billions of years. This story is an indictment of us, of how modern civilization has bound its survival to fragile systems out of sight. We have built a crystal castle on constantly vibrating magnetic ground. And the harshest truth space engineers have to swallow is, those systems don't necessarily have to collapse instantly to be dangerous. They just need to deteriorate faster than their own ability to repair themselves. Tomorrow, there might not be a widespread power outage. No satellites will fall from the sky in streaks of fire. Most of the world will wake up, see stunning aurora borealis photos on social media. The press will move on to a new topic, and everyone will breathe a sigh of relief. See? There's no apocalypse. But that silence doesn't mean nothing is happening, because when you understand how the universe works, you realize we've been asking the wrong question all along. The real question is never, how strong is today's storm? The life or death question that no one dares to answer is, how many more rotations before a crucial link crosses its final limit?